Section 11.3 is on using probabilities to make predictions. Let's imagine that you have a box with 50 marbles in it. And from that box, you pull out a sample size of 20 marbles. Inside that sample, you have 4 green, 10 blue, and 6 yellow marbles. From the information given, we can predict how many marbles there are of each color in the original population size. First, let's determine the probability that we will pull out a yellow marble. So once again, we said the sample size was 20, and we had 6 yellow marbles. So the probability that we would have a yellow marble pulled out is 6 over 20. The 6 represents the number of yellow marbles, and the 20 represents the total number of marbles in the sample size. So the probability of pulling out a yellow marble would be written as P for probability of yellow is equal to 6 over 20. So now that we know the probability of getting a yellow in the sample size is 6 over 20, we can use that information to determine how many yellows would be in the entire population. Now remember, this is only an approximation since there's no real way to tell besides actually counting them out. This just gives us an approximate amount. So now we want to figure out approximately how many yellow marbles are in the entire population. So what we would do is multiply the original population size by the probability of it being yellow. And if you do that math, you will see that it comes out to approximately 15 yellow marbles inside the original population of 50 marbles. Let's try an example. Let's imagine that you have a school population of 1,500 students. You pull out a sample size of 25 students. Within that population size, you have 15 boys and 10 girls. From this information, determine what's the probability of you pulling out boys in your sample size. What did you get for your answer? If you did it correctly, it should have looked something like this. The probability of boys is equal to 15 over 25. Did you get that? So now that you've gotten the correct answer, we now need to determine approximately how many boys are in the entire student population. So go ahead and give it a try. If you did it correctly, your problem should be set up something like this. You have 1,500 students originally, and you are multiplying it by the probability of the student being a boy. What did you get for your answer? You should have gotten approximately 900 of those students would be boys. Let's talk about grades now. Let's imagine that there are 200 students taking IA2 this year. We pull out a sample size of 27 students. And from those 27 students, 5 of them have A's, 6 have B's, 10 have C's, 4 have D's, and 2 have F's. What is the probability of students that have a C or better from that sample size? Because we're looking at C's or better, we need to include both the A students, the B students, and the C students. So that would have gave us a total of 21 students. So the probability of a C or better would have been 21 out of 27. Now that we have that information, we can determine approximately how many students in all of the IA2 classes have at least a C or better. So if you do your math correctly, it'll be 200 students is the original population size, and then the probability of having a C or better is 21 over 27. So if you do your math, you will see that approximately 155 of the 200 students have a C or better in the class, and that's because we are all awesome.